Okay, we're back. Hopefully you skipped the last 10 minutes. I just created a new folder and it now works. So kind of no changes in the code were actually made. So we're here and now we can run it like so, and it prints as intended. Okay. All right. So next, what we want to do is write validate string length, a list length, sorry. So basically what we want to do is double check that the size that's advertised in the LL is actually what it's supposed to be. So return 1 if the length matches, 0 if it doesn't match. So, okay, so I'll go and open my in U2. I'll go to my files here. So I'll go here. So I'll create a new function. So that's going to be int validate list length. Going to do like this. So basically what I want to do is I want to verify that this size is the same as the size of the linked list. So I go here. Now I'm going to define it. So basically what I need to do is I need to manually look at whether what the length is and then verify that it's the same as this guy. So how do I check the length of the list? Well, I go node by node until I encounter a null. So I'll have a current size, and the current size initially is going to be 0. And then I'll have my current, which initially is just going to be the head. And then I'll keep going until I encounter a null. And I'll increment current size and I'll switch to next. So I want to make sure that over here, I'm not off by 1. So the way I'll check it is, okay, so if this is 0, then current size will be 0 because cur is going to be null right away. If the actual size is 1, which means that initially current is not going to be null, but current next is going to be null, then yes, it is going to be to increment once, and then current will become null. So that's legit. And now I'll just return. So this converts to 1 or 0 in C. So this will be 1 if it's true, 0 if it's false. And if current size, which I've computed manually, is the same as the size, it's going to return 1. If not, it's going to return 0. So I can now test it. Like so. And I'm going to run it. And yes, indeed, it returned 1. So I can try to break it so that it doesn't work. So I can say like manually list size is 2, in which case it's supposed to print 0 over here. And indeed it does. So that's that. Here we want delete. So the function should take an index of a node that needs to be deleted, and update the linked list to remove the node. So, okay, I'll go to linked list.h. And it's going to delete at this index. So this is delete element. This, copy this into linked list.c like this. So what I need to do, so I need to basically remind you the way the deletion works is what we basically want to do. If we want to remove this, what we want to do is we want to say this next is now going to be this. So that means that I need to go, from 5 to 2 to 1, and then say, okay, like if the one that I'm about to delete is this guy, then I want to make this arrow point to the node that follows the one that I'm about to delete. So, okay. There is also a special case where I want to delete the 0. So let's do it first. So if index is equal to 0, then what we need to do is we basically need to say, okay, so I need to change the head, and then I also need to I also need to free the node that's after the head. So this is a reasonable way of going about it. So I'll remember the address of the thing that I'm gonna delete. The reason I'm doing that is because if I just free head, then I cannot access head next. So what I need to do first is I need to remember where the node at index 0 is, so that I can then go to the next. But that's for after. So I then update the head. And this might or might not be null. It doesn't matter. So if the list is of length 1, then this would be null. At this point, I don't anymore need to access list head next, so I can free temp. And now I also need to decrement the size, and I'm done. So I can just say return. So now end is not 0. So at this point, I just need to keep updating cur until cur next is the thing that I want to delete. So I'll start with cur being head, and then I'll iterate end -1 times. So I start with 0, I go end -1 times, and I just update cur. So at this point, I want to delete cur next, and I do it exactly the same way, right? So I define a temp node. I'll make the next be cur next. I free temp. I decrement the size, and I'm done. So that's delete. So that's kind of like that. So one thing that's not super nice here is that I repeated code twice, right? So I have this code and this code that's like almost the same, but there's not like an especially elegant, I think, way to get around this. So let's just test this. So I named it delete end, which I guess is not super consistent, but that's okay. So delete end like this. I'll say delete end, and let's say that I want to remove this guy. And I want to print it again. So to see that this is the other one, it's going to be first print this, then delete, then print again. We run this. And here we have, 1, 5, 10. And now we deleted the node at index 1. So now it's 110. Okay. So that was lab 6. I will take a short break and then I'll do lab 5. I'll